Today we're going to start with Chapter 3. We're going to focus on Section 1, which is identifying pairs of lines and angles. So in this slide, we're going to learn the difference between parallel lines and skew lines. Again, more vocabulary, so you definitely have to remember to make a list and start writing these vocab words down. So parallel lines are coplanar lines that do not intersect. So coplanar, meaning they're on the same plane, okay, same plane, and they never intersect. You learned about these in algebra. Basically, lines with the same slope don't intersect. And so parallel lines have the same slope, if you remember that from Algebra 1. So in this picture here, the white picture, it says line AB is parallel to line segment or line CD. And AB is parallel to CD, and we write it like this. So this is the symbol for parallel lines. Now, skew lines are a little bit different. Skew lines also do not intersect, but the difference is that skew lines are non-coplanar, so they're not on the same plane. And they are neither parallel nor intersecting. So they never cross each other, but they're not parallel to each other either. Okay, and the reason for this, that if they're on the same plane, they have to be parallel or intersecting. But being that they're not on the same plane, they could actually never intersect without having to actually be parallel. I think it's easier to, I think that drawing right there is a little bit complicated. If you think of a cube, let's think of a three-dimensional cube, okay? And what you're going to realize is, for example, this line here, this side, this segment of the cube is never going to touch this segment of the cube. And it's not because they're intersecting, it's not because they're parallel, it's because they're on different planes. Also wanting to make a note, one way that we identify parallel lines, if you notice, it's very hard to see, but you'll see those little arrowheads almost inside the line. So for example, if this line and this line are parallel, we'll put those little arrowheads to indicate that they are parallel to each other. So parallel planes are planes that do not intersect. So just like lines don't intersect, you can have planes that never intersect. And if we look at this cube as a representation, or this prism as a representation, you'll see the faces, interpret the faces as planes. That front face will never touch this back face. They are actually completely parallel to each other. So those would represent parallel planes. The top and the bottom are parallel planes. The left and the right side are parallel planes. So now we're going to talk about some postulates that have to do with parallel and perpendicular lines. The parallel postulate states that if there is a line and a point, so we have a line and a point that is not on the line, then there is exactly one line through the point parallel to the given line. So what this is saying is this. Let's say we start out with this yellow line and we have this point that's not on the line. What this postulate is saying is that I'm only going to be able to draw exactly one line through the point that will be parallel to the original line. Okay, I can't draw an infinite amount or more than one. I can only draw one parallel line through that point. Okay, so this would be parallel to that. The second postulate, the perpendicular postulate, says that if there is a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. So what does that mean? Well, again, I start with a line and I start with a point not on the line, and this is saying that I can only draw one line perpendicular to through the point through the original line. And remember that perpendicular means that it intersects at a right angle or at 90 degrees. Now, transversals are a new concept. A transversal is something we haven't discussed in this class. A transversal is a line that intersects two or more coplanar lines at different points. So, for example, we're going to start out with line J and line K. Okay, so notice we've got line J here, and we have line K here. So these are two lines. They're not parallel to each other. They're just two red lines, right? And notice that we have this blue line. I'll just kind of maybe put it in green here. This green line M. This represents a transversal, okay? And the transversal basically cuts through the other two lines. It intersects line J here at this point and line K here at this point, okay? And what happens is when that transversal cuts through, it creates 8 angles here. It creates 4 angles with line J, and it creates 4 angles with line K. Now, the interior angles are the angles that end up on the inside of the two original lines. Like, let's just, here's think of the two red lines like they sandwich this interior space, right? So our interior angles are the ones in between those two, so it's angle 3, angle 4, angle 5, and angle 6. The exterior angles are the ones on the outside of those red lines, and so that's angle 1 and angle 2, angle 7, and angle 8. And again, lots of vocabulary here, guys. Definitely want to focus on the vocab. So when I say interior, I'm talking about things that lie in between the red lines. These are your interior angles in there. Your exteriors are out here, okay, the ones on this side. Now that we know what interior and exterior are, and just to kind of be consistent, let's just kind of go with red again, right? We've got lines JK, we have this transversal here, M, and we have the interior, which I'm going to shade off for us again. And so we know that this is the interior angles in here, 3, 4, 5, 6, and exterior are 1, 2, 7, 8. But then, more specifically, we talk about alternate interior angles. And alternate interior angles are two non-adjacent interior angles on opposite sides of the transversal. So non-adjacent means that they cannot share a side. They're not next to each other, right? So let's think about what this says. Two non-adjacent interior angles on opposite sides of the transversal. Well, if the transversal's in green, we see that angle 3 and angle 6, those are on opposite sides of the transversal, and those are not adjacent. So angle 3 and angle 6 meet the definition for alternate interior angles. Another pair of angles that meet that are 4 and 5. Angle 4 and angle 5 are on opposite sides of the transversal, the green line, and they're not adjacent. So following that, we go to the definition for alternate exterior angles. It says two exterior angles on opposite sides of the transversal. So once again, let's think about that. Exterior angle, like number 1 and 8, are on opposite, they're both exterior, and they're on opposite sides of the transversal. So angle 1 and angle 8 are alternate exterior angles. And then following that, angle 2 and angle 7 are going to be alternate exterior angles as well. So again, kind of look at it, start to learn the differences. Again, you want to differentiate between the interior ones and the exterior ones, and then alternate ones. Understand what we mean by that. There's a couple more here, and again, what we're going to do is we're going to stay consistent, right? We started with with line J, we have line K, we have our transversal here in green, and I'm going to do the same thing. I'm still going to color in here the interior portion of all of this, okay? So I know the interior is here in between J and K. And so the next thing we're going to talk about are same side interior, or also known as consecutive interior. Okay, so that has a couple of names, aka consecutive interior. Same side interior, again, think about it. Interior is angles 3, 4, 5, 6. Which ones are on the same side? Well, 3 and 5 are on the same side. And what we mean by that is interior angles that are on the same side of the transversal. So angle 3 and angle 5 are on the same side. Angle 4 and angle 6 are interior angles that are on the same side of the transversal. So they are same side interior and or known as consecutive. They say consecutive because notice that one follows the other. You know, they're kind of like in a row there, but I like same side interior better than consecutive. And the last relationship that we're going to talk about on this slide are corresponding angles. So let me just kind of erase this a little bit. Let me get us back to where we were. Now, corresponding angles are unique. Corresponding angles, these are not, we're not talking about interior versus exterior like we've been doing with all the other ones. Corresponding are angles that are sort of in the same spot. In fact, let me just kind of erase the whole interior because corresponding angles doesn't really go with interior and exterior. So again, let's come back here. Let's just draw our J. Let's draw our K. Okay? And we have our transversal, which is here. The corresponding angles are two angles in corresponding positions relative to the two original lines. Okay? So when you think about it, we have, for example, we have line J and line K. And if you notice, angle 1 is on the top left of it. Well, angle 1 will correspond with angle 5 because angle 1 and angle 5 are on the top. They're on the top of their respective lines, J and K, and they're on the left side of the transversal. So following that, another pair of corresponding angles would be, for example, angle 2 and angle 6. And why would that be? Well, because angle 2 and angle 6 are both on top of the lines, J and K, the red lines, and they're on the right of the transversal. So now if you follow that, then we say, well, angle 3, let me do a different color, hold on. Angle 3 is below line J on the left side of the transversal, so angle 7 is below line K and on the left side of the transversal. So angle 3 and angle 7 are corresponding angles. And our last angle that we're going to talk about is going to be angle 4 and angle 8. They're both on the bottom of their lines on the right of the transversal. So angle 4 and angle 8 are also corresponding angles. So let's do some true and false questions that come from that. A transversal intersects only parallel lines. Well, you saw that lines J and K were not parallel in those last examples, so this is false. A transversal can intersect any two lines. Skew lines are not coplanar. True. If two lines are coplanar, then they are parallel. That would be false. And again, remember, we're thinking of, this is a conjecture, let's say. We're thinking of a counterexample. I can have these two lines are coplanar and they're not parallel. So definitely false. And then D, if two lines are parallel, then exactly one plane contains them. And that would be true, because remember that parallel lines are coplanar. And so they're on the same plane. Now we're going to go to, I believe this is example 3 in your slides. I think I'm missing a slide here. I think this is example 3 on your student version. So let's do this one. Alternate interior angles. Well, again, let's be consistent, right, so that we can kind of get used to this. We're going to do our two lines in red. And we're going to do our transversal in green, just like I've been doing, right? This is our transversal. And I'm going to identify my alternate interior angles. And since I'm going to be doing that, I'm going to also kind of color the interior, just like I did in the slide, so you can kind of see it, okay? Everything in yellow, those 4 angles in yellow, those are the interior angles. So when I'm looking for alternate interior angles, I'm looking at angle 2 and angle 7, because those again are interior and they're on alternate sides of the transversal, as are angle 3 and angle 6. So those are two pairs of alternate interior angles. When I go to consecutive interior, notice consecutive and interior. So I know I'm looking at angles on the inside or interior of the red lines, and consecutive means same side. So the same side interior angles are going to be angle 2 and angle 3, and angle 6 and angle 7. In C, corresponding angles, remember these are angles that are in the same location relative to the original two lines. And so for this one, I know that, for example, angle 1 and angle 3 are going to be corresponding, because again, angle 1 and 3 are to the left of the red lines and they are above the transversal. My next pair is going to be angle 2 and angle 4. Angle 2 and angle 4, here and here, those are on the right side of the lines and they are above the transversal. And going with that, I'm going to have angle 5 and angle 7 are also corresponding, and angle 6 and angle 8. So those are my 4 pairs of corresponding angles. And then the last thing we're going to do is alternate exterior angles. And so alternate exterior angles, again, alternate meaning opposite sides of the transversal, exterior meaning on the outside of the red lines. So alternate exterior would be, for example, angle 1 and angle 8, and angle 5 and angle 4. And so, as you guys know, just like everything else we've been learning in this class, is that we have to memorize, memorize, memorize. You've learned a lot of vocabulary words in this section, and you're going to have to really spend time trying to memorize them, understand what alternate means, understand interior and exterior, understand what consecutive means, and once you sort of understand what they mean, then when you read it, you understand exactly which angles they're referring to. Okay, I added this drawing in here because I think this is example 2 that I was missing. Okay, this is the slide that I think I'm missing and you have as example 2. So if you notice, you've got this cube or this prism and you see all these faces. We're going to assume the faces, or we're going to look at the faces as planes. We're going to look at the edges as lines, okay? And we're going to try to figure out which lines or planes appear to fit the description. So in number 1, you should have one that says, name or list the lines parallel to line CD containing point A. And so again, let's kind of look at where A is here. And so notice that you've got this original line CD and you have a point not on the line. And remember that we found that there's only going to be one of the postulates we did there says that you're only going to have one line that's going to go through a point that's going to be parallel to the original line CD. And so that line is going to be line AB. Okay, this is going to be the line that is going to be parallel to CD. The next one says a line that is skewed to CD and also contains point A. So we're looking for a line that is skewed to CD and contains point A. So first of all, it's going to be a line that is not going to be on the same plane as CD. Notice that AB is coplanar, so it's not going to be that line, plus it's parallel, not skew. So the only line that is going to go through point A that is not going to touch CD is going to be AH. And the reason I know that is because AH, it's non-coplanar, it's non-parallel. And so that's the line that they're discussing or they're talking about in this problem. In C, it talks about lines that are perpendicular to CD and contain point A. And once again, we talked about that in the perpendicular postulate that said that if you have an original line, CD, and a point not on the line, A, you're only going to be able to do one perpendicular line to it, and it's going to be this one. It's going to be this blue line AD. So it's going to be line AD. That's the one and only perpendicular line that'll go through A and hit CD. And then the last one says a plane or planes that are parallel to plane EFG and contain point A. So again, I've got to figure out which is plane EFG, and I notice immediately that plane EFG is this bottom plane. Remember, the bottom face is what we're kind of calling a plane. So what plane is parallel to that plane and contains point A? Well, it's going to be this plane up here at the top. The bottom and the top are parallel to each other. So the plane that answers this question is plane CDA. Remember, I can name the plane with any 3 points that are on the plane. So it could be plane CDA, I could have chosen DCB, any of 3 of those 4 points would have named it. And so again, these are the answers to example 2. And that's it. There's a homework assignment on Big Ideas Math for you. And we'll go over it tomorrow, next class.